Our next speaker is local. He's a graduate at FIT-STU, and he is focusing on usability. He will be walking us through his experience with eye tracking, and he will tell us more. So please, Róbert Móro.
Okay, hi. Good morning, everyone, and thank you for introducing me. So I'm a PhD student here, but I also am a researcher in a user experience and interaction research lab that we opened here at the faculty in May last year. You may have heard of it because our professor that opened this event talked about it last year at World Usability Day. So I will not go into detail of the lab, but I will make a short introduction of what we have. And today I will speak not specifically about my work, but what we as a research group have been doing since the opening last year. And so the main thing that we are focusing on is actually this influence of personal characteristics. So how people that interact with the computers, how their characteristics influence this interaction, and when we invite them to be our participants in the usability or user experience study, how these characteristics will influence the output of the study and the results that we are getting. So to the introduction of our lab, so it actually consists of 3 laboratories. First one is what we call a Sensor Lab. So it's basically for testing applications that are desktop or web applications. Basically everything you can project on a screen of a computer. So this is how the room looks like, and this is the eye tracker that we are using. It's 300 Hertz Tobii eye tracker, and behind this window is actually an observation room, so you can in real time see how the participants, what they are doing. So it's good if, for example, we are testing an application, we can invite people, designers, programmers, or also people who make the decisions, the managers, and then they can see how it actually works during the testing. And then we have a lab that's used for mobile testing. So in the stand, you can put a tablet or a mobile, and you can see we have also a TV, so we can have a setup in which we track where people look at the TV. Yeah, for this we have a 60 Hertz eye tracker. And then what probably is kind of specific is that we have also a UX group lab. I personally know maybe about 3 or 4 other labs like these in the world. Maybe there are more, I don't know. But so what makes it special that we have actually 20 working stations. Each one is equipped with an eye tracker, and so we can scale up our experiments, test up to 20 people at once, and of course it can be used also for use cases that, for example, expect that you have some collaboration between the users, between the participants. And what connects all these 3 parts, so these laboratories, that we have our software infrastructure. So we have the software that's from the vendor, we have eye trackers from Tobii, so they have their Tobii studio, and each of the stations is equipped with the Tobii, but it's useful only if you test one participant at a time. So we made a tool that basically distributes the experiment, the study to all the working stations and then collects the data. And beside this, we have our own custom-built software infrastructure that allows collection of the data from all the stations and then to analyze it. So that's basically our lab, what we have here. And now I would like to talk about this direction that we've taken, and it will be more about different research topics that we are examining here. So I hope it will be interesting for you. So our motivation, as I already said, is that personal characteristic of participants can affect results of usability studies. So not only the design of what we are testing, but also of what people we invited to test. And this can be influential because if we have a low sample, like 5 people, we would like to know them better, what people they are, what characteristics they have. So what characteristic can be interesting for us? It's maybe like the cognitive abilities, so how fast they can process information on the screen, what is the size of their working memory, so how many things they can remember, maybe what personality type they are, because in some task, if they are not successful, this can influence that they will be frustrated, maybe they give up sooner than other people. Also, people that we invite might have different familiarity with the interfaces. So I don't know, if we invite maybe older person, he or she will not know how to work with a smartphone because he or she doesn't own one. And also the current emotional state of the person might come into play. So these are all the things that we might want to measure and how this can influence the test. So for example, if we want to test the design of an e-shop and task would be to buy a product and go to the checkout, it might be easy task for someone who already visited the e-shop, or so for someone who is familiar with the e-shops in general. So I would know, for example, that I should look for this icon of a cart. And it usually will be in the top right corner. But maybe someone who didn't do it before, he wouldn't be familiar with it. And so our goal, as I said, is to get to know our participants better, to identify their characteristics and differences in these participants, and then use it to help us interpret the results of a study. And how we want to get to know them better, well, we could ask them, but there are, for example, different personality tests from psychologists, but these are very long, and it would take really long to get all this information. So our research goal is to design a set of, let's say, calibration tests or tests that can tell us about the participant more, but wouldn't take much time. So basically, we observe how they interact with the application, and then they try to infer these characteristics that I was talking about. And the first thing that we looked at was visual search ability. So if you are not familiar with it, there are these standard tasks that psychologists or I think neuroscientists also examine. That you have some kind of target, and then you would try to locate this target among other ones. They are called distractors. So and the task can be that it can be present there, but it can be also absent, and you have to decide whether it is there, and if it's there, to locate it on the screen. So it's here, right? And normally these tasks are easier. So basically the standard task, for example, this is an easy one. It's called conjunction search. So you have just like 2 kinds of shapes and 2 types of colors, and you have to locate a triangle that's blue among red triangles and blue squares, right? And so our research question was whether these kinds of tests can tell us something about the participants, whether this can help us to predict when they face findability tasks, so tasks that suppose that a participant should locate a button or click on a link or something like that, and they have to find it on the web page. So how this ability would predict their, for example, time that would take to locate this button on a web page. So what we did was that we conducted a study with 45 participants. We tested each participant on this kind of task. This is the visual search classical task, and then we also used this may be more complicated because there is much more variability in the target and in the distractors. So we used the web icons, and then we tested them on 15 different web pages to asking them to locate some kind of information or a button or anything, and we measured their reaction time. A number of fixations. So fixations are basically when you analyze eye tracking data, when you look at something, well, your eye makes rapid movements, but for sometimes it stops, then it processes the visual information and then it moves again. So we measure how many stops are there in the output from the eye tracker. And what we found out, or the first results that we have from the data analysis from this experiment, is that actually this visual search ability measured on these kind of tasks can help us to predict how long will it take participants to do or to be able to perform these findability tasks. And we found that these icon tasks, so it's this one, is better in predicting their performance than the conjunction search. That's the other one. And what was interesting that when you have tasks where there is no target, when the target is absent, this is better predictor. So based on behavior in these tasks, maybe because it basically forces you to try to scan sequentially, and you have to decide what strategy is best. And then this maybe helps to differentiate how people would behave also on a real life stimuli. So, and we found, for example, that very good predictors when we have a test with 64 elements, so maybe something that you saw a few slides back. And that's nice because it means that we don't have to have like, I don't know, 90 stimuli, different number of elements, but maybe we can just use this one and it will help to tell us what participant is sitting at the computer. Okay, the second thing that we are currently researching is cognitive load. And cognitive load basically, well, it's something when we have a task and we have to like do some cognitive activities, some thinking. So basically it's a good thing when it's induced by the task. But if there is an extra cognitive load that's because of the interface, that can be bad. So the interface should not come between me and the task. It should help me to do the task. So I have to think more because I'm uncertain, because I don't know the interface, or the interface is not helping me. That would suggest that there is some maybe usability issue, and I should design the interface differently. And we can measure this also with the help of an eye tracker. So we can look at the pupil size of an eye, okay? And if people have to think more, or the cognitive load is higher, then the pupil gets larger. The problem is that it responds to many other factors. So it's like emotions. So if you are stressed, your pupils would get higher as well, larger as well, and also to the light conditions. So if it's darker in the room, the pupil will be larger. If it's more light in the room, it will be smaller. And also it depends on the light emitting from the screen. So if you have, for example, black screen, it's different than the white screen. And it's very hard in psychology studies. You can control these conditions, but when working with like real stimuli, web pages, applications, you cannot do that because they have different colors. They are different. So we would basically like to filter out these effects, just to have the idea what's the part in the change of a pupil can be attributed to cognitive load, and what part was the different things that we are not interested in. And for this purpose, we proposed a model of this pupillar response, so how the pupil changes based on the light. And we designed a calibration procedure, so we show participants different screens of different colors, and in this phase we see what is the range of the pupil size, because it's different for each person, and then we can compute for each pixel of the screen what its luminosity, so it's light, emitting light, and then we have this model computes like what pixels attribute to this to this whole luminosity of the screen, and based on where the participant is looking at. And the good thing is that the test takes less than 2 minutes, so it's something that we can have at the beginning of a usability testing, and then we don't have to care about it because we have the model for the participant, and we can then compute the cognitive load. And again, and then the cognitive load is our model predicts what the pupil size would be if there were no cognitive load, just based on the screen. And we measure the actual size from the eye tracker, and the difference would be cognitive load. And we evaluated with 50 participants. You can see how it looked like. We projected them different kinds of screens. Currently, the model has less than 5% of the range with monochromatic stimuli and about 15% for colored web stimuli. But even with this kind of precision, we are able to differentiate 4 levels of cognitive load, which we evaluated on different kinds of tasks. It was like mathematics tasks, Sudoku, and so on. So we chose different tasks of different some were harder, some were easier, and we were able to differentiate 4 levels of this. And the last thing is that I want to talk about is emotion detection. And again, why we are interested in emotions, in measuring emotion, is because when we observe that there is some negative emotion, maybe frustration during the testing, it might be a result of an error or an issue with the design. And there are different ways how to measure emotions, and what we focused was using EEG. So there are different kinds of EEG. What we worked with EEG that's not so not so expensive. It's called emotive epoch, and it looks like this. So you don't have to wear a cap. It's the data transmission is wireless, and you just use some salt water for the electrodes, not some gel or anything. So it's not so bad for the participants. It's quite all right, and the setup doesn't take so long. And we proposed a method, so how to process signal that we are getting from this EEG device, and how we can then see what emotions people have. And in our experimental setting, for the moment, we use music videos. So we showed people different music videos that were supposed to induce different emotions. We asked them after watching the video what emotion they felt when watching it, and we use it as to train our model that then was able to predict correct emotion with 58% accuracy. It's not perfect, but it was for 7 emotional states, not just 2. And maybe for in practice, for usability testing, we just need to know if it's negative or positive. So maybe we should, or neutral. So maybe we are okay with 3, not with 7, then the accuracy would be probably higher. And I think it's all. I'm not sure how I'm with time, but thank you for attention. If you are interested in our lab or in research that we are doing here, there are some links that you can click on. Thank you for attention. Okay, so the first question, from my point of view, was the single most useful eye tracking metric. I think it's cannot be said like this. It highly depends on the task. But usually, what you would analyze are, for example, how many people fixated on an area of interest, and then from those people, how, for example, if you have something that needs to be fixated as quickly as possible, then you look how long did it take to look at the area of interest. But it really depends on what you would like to know, whether it was visually appealing or whether it was not confusing. What's nice about an eye tracker that it can give you more information than just when you just observe clicks, because if people, for example, are not clicking on a button, it might mean that they are not seeing it, but it might also mean that they are seeing it but not understanding, not associating, for example, the label with what they are supposed to do. maybe something is confusing for them, and with eye tracker you can differentiate these issues. So that's the nice thing. But I wouldn't say that there is one single most useful metric. Okay, so next question: can visual searchability be trained? Well, that's an interesting question. I'm not sure really. I guess that in some way yes, but I think there are limits to what you can train. So you can maybe train for a specific task, but if you then change it somehow, it's obvious that if you are doing it for the first time, that you will be not as good as the second time. So for this reason, there is some short training phase. So first we show participants what they would expect, what the task looks like. They do a dry run, so just try a few stimuli. So they are trained in a way, but I'm not sure if you would do it like 8 hours a day for a month. You would get better in the end, maybe, but that's probably more for a neuroscientist question than for me. Next one, users need to participate. Okay, yeah. So statistically significant results, that again cannot be answered in general. I think it depends on many factors. In literature you would usually get if you want one answer, then it's maybe about 20 or 30 people, but it depends on the effect that you want to observe. So if you, for example, have two designs, and I don't know, task time is the metric that you are interested in, and you expect the other design to perform much better. So I don't know, it will be 30% shorter than the previous design. Then you will be able to find this difference with a lower amount of people. But if the effect is I don't know, 5%, but maybe for your use case that's okay, then you will need more people because the effect is much smaller. So it cannot be answered in general. For example, if you are just interested in finding usability problems, issues, so not comparing metrics, then there are again some recommendations on the number of participants, but this depends, for example, how probable is that the problem that someone will stumble on the problem, and it's not so easy to have an intuition about the probability. So maybe if you did the study in the like previously and now you are doing a redesign, that should maybe give you an intuition of the effects. And for example, if you did just a new design, then it's probably there will be more problems, so you will need fewer people to locate the most serious problems. All right, so the question is whether our findings are somewhere publicly available. For the moment, we are, because we are a university and there is this publish or perish theorem, so we try to publish our results first, and things that get published are available, but it's not, the problem with the research is that it's behind these publishers like ACM, IEEE, so it's there, but if you don't have access from your university, it's not so publicly available. We also have our webpage where Maria tries to urge us very hard to write a blog post about what we are doing here. So I guess in the future there will be more information about our work publicly available in a more, let's say, accessible way, also for the general public, not just for researchers in a form of a research article. But for now, I guess some of it is on the webpage, but not all of it. And we have also seminars of our research groups, and there are presentations. So if you look at our webpage, these presentations are publicly available, so you can see what we are doing here. But probably that's not the best way what you would be interested in. Okay. If that was the last question, then once again, thank you for your attention.